Okay, let's do the last 4 or 5. And derivative of arcsecant. That's the weird one with the absolute values. So again, it's nice to memorize them for the test, but I usually forget them if I don't use them the prior day, so I pretty much have to derive them quite a bit. Hopefully you can do that pretty quick by now. So it's absolute value of x times the square root of x squared minus 1. But this is also a chain rule, so then times the inside. So the whole thing oops, that should have been squared. And I can't really get rid of absolute values because there will be some negatives there, so I need the absolute values. Nothing cancels, so it looks good. Looks like I changed the order here when I changed the format of the quiz. So let's do 18 first. This is a fundamental theorem question. If the x was on top and 1 was at the bottom, you would just take the derivative, it'd be 1 over x. Since it's the wrong way, you're going to have to change it first to the right way. And if you remember the properties, that's going to be d dx. And now my new insides here are going to be negative. And since I made a negative, now I can go from 1 to x. 1 over t dt. And since that's true, now I know the derivative of this is 1 over x. There's my negative. (17) a little more complicated since it has a couple functions of x. So when you do these, remember you're going to plug in the x cubed and the x squared, but then you also have to multiply times the derivative of those two. It's kind of like chain rule. So it's going to be sine squared of x cubed. There's my derivative, minus sine squared of x squared. And there's that derivative. So there's my original function. Okay, 19 kind of required you to do logarithmic differentiation, although there were a problem here earlier where we had to use it also. So we'll rewrite this log y, natural log of this side, and so that's going to get me log y 3 ln x minus 1/2 ln x squared plus 1. Derivative becomes pretty easy at this point, 1 over y prime. So this part does become implicit. 3 over x minus 1 over 2 x squared plus 1 times the derivative of the inside, which would be 2x. Cancel out the 2's. Multiply both sides times y. And now we've got y prime equals 3 over x minus x over x squared plus 1. Don't really need the parentheses anymore. And times y. Well, up there was the old y. So that's x cubed over the square root x squared plus 1. That's your full derivative. Alright, last one, second derivative with an implicit. Okay, so the first part's pretty easy. The first derivative, 6x minus 8y equals 0. We'll solve for y prime, so subtract 6x from both sides and divide by negative 8y. Simplify 3x over 4y. So we might need this result later. Second derivative. We're going to start with our first derivative and just use the quotient rule. Oh, I changed my y kind of into an x there, make sure it looks like a y. So, O, derivative of the top is 3 minus high d ho, just a 4, but don't forget the y prime, over ho squared. Remember, it's the whole thing squared. 4y squared, which is 16y squared. Looks like there's some 4 here's that can cancel. And so now we get 3y minus 3x y prime over 4y squared. But remember, this y prime is really 3x over 4y. 3x over 4y. So let's go ahead and see if we can get this fraction together, get rid of our complex fraction here. So we'll multiply both sides times 4y. So now we've got 4y times 3y, 12y squared. And this fraction's already good, so minus 9x squared all over 4y, and dividing by that's the same as multiplying by the reciprocal. Final answer, nothing I can cancel out. 12y squared minus 9x squared, 16y cubed. And that's the quiz we took. Practice these until you can do them well. And you should be rewarded, because when we get ready for quiz 2, there will be a lot of problems that use the same techniques.